Hey, Julia.
Hello.
Hope you're having a great night and glad we're able to connect a little earlier. Hope school's going well. Have you had your spring break already?
Yeah, I just had it.
All right. So got just somewhere between 6 to 8 more weeks and you're probably done.
Yeah.
What did you want us to look at tonight, or what? Oh, I see you did send something over by email.
Yes, I have a quiz tomorrow.
Fantastic. So should we do these problems again? Would you like some like it? What would be best to help you?
If we could do some like it, because there's some parts that I do know, but there's some parts that I'm a little confused on.
Sure. This page you sent me is really well organized. I'm gonna just have to work on it sort of vertically, so you'll see. We'll cover all of these things, but you may not you may not actually see them in such a nice order. But let me get my screen sharing going, and we'll get started here. Okay, so let's look at something pretty straightforward. Let's go log. Let's say f of x equals log base 2, and we'll go x minus 2. And I guess, is it okay if I add something on the outside here? Is that something you've seen before?
No.
All right, I will be removing that. Okay, there is only one transformation, and it's from inside the parentheses here. It's just like when you're graphing quadratics. It's the same principle.
Okay. It is a horizontal shift right 2.
Yes, perfect. All right, fantastic. So now the next thing it looks like your instructor asks for, and I guess maybe I'll center this a little better. That's thing 1. So thing 2 will be, what is f of 0? And that means to put 0 in for x. And if you simplify, we have a problem here. The log, this part inside here, this has to be positive. And that's why you may have wrote undefined for quite a few of them. How about f of 1? What would that be? Or how would that be any different?
F of 1.
So this time you're putting 1 in for x. And it's log based.
-1.
It is -1. Can you evaluate the log of a negative number?
No.
No. So this one is also undefined. It's kind of an odd thing to ask for, because you don't generally get a generally want to do stuff that works out nicely, but unfortunately that's not possible here.
Okay.
Right? All right, so I'm just going to grab the graph, I'm sorry, the equation again, and then I'm just going to snip it, and we'll keep going with this list. So the third thing you might be asked for is the domain. So the domain is, you set the inside part greater than 0. So you literally say x minus 2 greater than 0. And then you solve for x. Add 2 to both sides, so x is greater than 2. And so that's your domain. Your domain is, and it includes this part here. It's x such that x is an element of the real numbers, comma, x greater than 2, and then use these curly braces here on the outside. So that's your domain.
Okay. So when you were solving for x, when it's the x minus 2 is greater than 0,
Yes.
so all you did was use what's in the parentheses from the original equation and
Yes.
set that equal to 0, or set that greater than 0.
Yes, and you always do that.
Oh, okay.
Always do that.
Okay.
Now the range is nice. It's almost always, and I want to say always here, it's always all real numbers.
Okay.
I don't believe there is an exception to that.
Okay.
So again, like sometimes we get so far away from the actual like problem. We gotta almost reset here each time because you gotta so many things going on. So the fourth thing that they ask you for is the equation of the vertical asymptote.
Mm-hmm.
And this time you set the inside part. You set inside parentheses equal to 0. So you literally set x minus 2 equal to 0, and then you solve for x. You can see it's the same as the domain, except it's an equal instead of a greater than.
Okay.
Add 2 to both sides. X equals 2, and that is your vertical asymptote.
Okay. Okay.
Okay, so now like I guess I kind of want to deviate from where it says end behavior and move to the graph.
Okay.
But that's only if you're if everything we've done so far is clear.
Yeah.
Okay. So when you're graphing this, and I guess I gotta keep writing that. The first thing you graph is the vertical asymptote. So the vertical asymptote is at x equals 2, like this.
Mm-hmm.
And that's a dashed line. So the first thing you want to graph the vertical asymptote. The second thing you want to graph is the x-intercept. These always have one. It says maybe none. That's not true. These always have one. So the x-intercept comes from setting, from remembering a property of logarithms. So the property is log base b of 1 is always equal to 0. And so it doesn't matter what is inside, whatever the base is, when the inside part equals 1, that's when you have an x-intercept. So what you do is you set the inside part, inside parentheses, equal to 1. So notice with the domain, you set x minus 2 greater than 0. For the vertical asymptote, you set it equal to 0. Now you set it equal to 1. And then you solve for x.
Okay, so in this case, it would be, okay.
3.
Okay, that makes sense, yeah.
So when x is 3, it crosses right there. Boom.
Okay.
The third thing you might think to graph is the y-intercept. And this unfortunately, your instructor's right. There may be none.
Mm-hmm.
So if you go back and look at the domain says it's only good greater than 2. So it's over in this right space. And see where the y-intercept is? It's left.
Mhm.
So this one does not have one. Now there's another way we can do this, but we kind of already have, So the y-intercept is basically f of 0. And do you remember what we wrote when f is 0? F of 0 earlier?
F of 0. Oh, f of 0.
See how we did it right here in step 2, f of 0.
Mhm.
What do you see here as the answer?
Undefined.
Undefined. So that means it does not exist. So in this case, it's undefined, which is why there is none. So there's 2 ways to do it.
Okay, so you set the y-intercept to 0.
No, you try 0 for x. But we already did that, and that's what I was trying to show you, is that we have actually already calculated this. This is putting 0 in right up here where x is 0.
Oh, okay. So,
And it's undefined, like it doesn't work. So there is no x-intercept. I'm sorry, y-intercept, which is why it says there may be none.
okay, so to find that, you just plug in 0.
Yes, for x. But in this case, there is none, so you don't have to do anything else.
Oh, okay. So plug in 0 for x to find the y. Okay.
Yes. All right.
Okay.
Do you remember what the parent function graph looks like for log of x?
The parent function, it crosses through.
So let me show you, and then you could, maybe this will remind you here. So do you see that this is the graph of log x? It goes up and to the right.
Yeah.
And you saw that from class.
Mhm.
And like if I change the base, it still goes up and to the right.
Mhm.
I'm just changing the number here. It always goes up and to the right. Okay.
Okay.
So the reason I show you that is because when you graph it, you want to get this shape. You want your graph to look similar. So
Okay.
the graph does something like this. Now, from class, do you remember how many points your instructor wanted when you graphed it? Because it says label key points.
I think he wanted 2 or 3.
Okay. So 2 points, we've already got 1. We have to like now understand how to evaluate log.
Mhm.
Okay. And I'm not sure how comfortable you are with that. So let me come off to the side here. Log base 2 of x. If we make a table here and we let x and y be our values, let me grab a few in here. So when x is 1, this is y equals log base 2 of 1. And that is 0. No matter what the base is, when you have a 1 here, it's always 0.
Okay.
When you put 2 in, this becomes y equals log base 2 of 2. And do you know what this evaluates to? That's kind of our starting point here for how much to explain.
Is it 1?
It is 1, yeah. And the reason it's 1 is because there's an exponent of 1 there. And we can talk about that if we need to, but let's look at one more. That's no good. Let's go ahead and write 4 here. y equals log base 2 of 4. And that is log base 2 of 2 squared. So this equals the exponent, which is 2.
Okay.
I'm hoping you've seen that before. So now when we go back to your problem, okay, remember how we set x minus 2 equal to 1 for that first point?
Yes.
For the second point, you're going to set the inside, the inside of the parentheses equal to the base. So see how the base is 2? You want to set x minus 2 equal to 2.
Okay, so you took the parentheses x minus 2 and set that to the base.
Yes,
log.
to
Okay.
get your second point, which is going to be, we don't know what it is, it's going to be x equals 4.
Okay.
So when x is 4, okay, the y value, whenever you follow this path, the y value will always be 1. And that's your second point.
So the okay. Nice.
So the first point here is 3, 0. And the second point is 4, 1.
Okay.
And then your shape of your curve has to be, I don't know what your instructor's been using, but like something like this.
Yeah. Okay.
Okay, so the graph is what allows us to talk about what the end behavior and the increasing and decreasing look like.
Mm-hmm.
So the increasing and decreasing are actually more straightforward to talk about. So let me go ahead and put those in. So unfortunately, I gotta like, go down here and grab the graph again, but it's increasing and decreasing. And the graph, again, it's something, it looks something like this. Okay. So increasing means it's going up and to the right. So do you see how this graph is always going up and to the right?
Yes.
Okay. So the answer here is that it's always going to be either increasing or decreasing. Like it's going to be one or the other. So in this case, it's increasing when x is greater than 2. It's basically the domain. Because it's always going up and to the right.
Okay.
Decreasing, none.
Okay.
All right, so now the next thing we can talk about is the end behavior. Right, and the end behavior is, you would say as x goes to, and we'll do infinity first, positive infinity. And basically this means to the right. And it's basically saying, okay, as you go to the right on this curve, what happens? And maybe from class or maybe from pictures, you've been told that it goes up forever.
Mm-hmm.
And when it goes up forever, that means f of x goes to positive infinity.
Okay.
Now the other direction, it's a little bit different. It's not negative infinity. It's as x goes to, and it's whatever the vertical asymptote is. So if you go back and look at our problem, it was 2. as x goes to
Mhm.
2. And really this means to the left. So when you go to the left on this curve, what happens? Well, it goes down. How far does it go down? Well, it goes down forever. So this is like down and this is up.
Wait, so for the second one, why does it go down?
So you say as x approaches 2, which is the vertical asymptote, you're going left this time on the curve. So you're going left. And the first way you're going to the right.
Oh, okay. So the second line of, so like the second line, like the x, the 2, that then you switch to the left.
Yes. Yes.
So you do one to the right and then one to the, okay, gotcha.
Exactly. Exactly. Yes.
Okay.
Okay. If all of that was clear, we
Mhm.
will do another one and just go through the same thing.
Okay.
Is that okay?
Yeah.
All right. Okay, so let's say your f of x equals 3. Actually, let me change it. Let's go 2 log base 3. For this time, we're going to go x plus 2. No, we'll go 1. We'll go 1 there. Okay, so there are transformations. This time there are 2 of them. Can you tell me what either of the transformations are?
Yeah. So the first one is the 2.
It's actually inside here. It's the order does matter
Oh,
here.
okay.
Yeah.
So that one is +1. So it's a horizontal shift left 1.
Yep, left one unit. Okay, and now the 2 out in front, what does that do?
The 2 out in front is a vertical stretch of 2.
Yes. Fantastic. All right, so the next thing it asks for is the for you to find f of 0. Okay, so if you don't mind, if you could just try working that out on your own, you're just putting 0 in for x.
Okay.
And I'm just going to step aside for like 10 seconds. I got to turn some lights on.
Okay.
All right, what did you come up with?
I got 2 log base 3, and then for the final answer, I got 1.
So the log of 1, doesn't matter what number is here. It could be 2, 10, a billion, pi.
Mhm.
This part is always, whenever there's a 1 there, this is always 0. So the property is log base b of 1 is always 0. Like this is something you have to remember, just like
Oh,
you
okay.
know how to multiply or divide.
Okay.
So this is 2 times 0, which is 0.
Okay.
Okay, which is not undefined. It's just 0. Okay. So let's do another one. Let's do f of 1. F of 1 is 2 log base 3 of 1 plus 1.
For that one, you get 2 log base 3, 2.
Yep.
And then 2 times 2 is 4?
Actually, this one we don't know the value of. So, and like this is it's not a friendly. It doesn't resolve nicely, but it is a number. Like if you had a calculator, you could get something that you're used to seeing, but it's not a nice number. So we just leave it.
Okay.
But it's not like the last one where it's just undefined. It's just that's what it is. So the domain is the next thing we look at. The domain, you set the inside part, and let me go grab the function again. We're getting so far down here. You have to set the inside part. Why is that happening? Okay. So you set the inside part x plus 1 greater than 0.
X is greater than -1.
X is greater than -1. So I'd like to fully show that you go x such that x element of the real numbers, comma, x is greater than -1. And you gotta do it this way.
Okay.
All right, what is the range? It's always the same in all these problems.
Yeah, it's just the y. I don't know how to say it, but there's it's the first.
Yeah,
It's
it's
all real numbers,
all
right?
real numbers. Yeah, and
Okay.
so you actually can say all real numbers out loud, but you have to write this.
Yeah. Okay.
All right, so the next thing is the equation of the vertical asymptote.
Mm-hmm.
So you find the vertical asymptote by setting the inside part equal to 0.
Okay.
So x equals -1. And that's really useful for graphing. Like you should immediately go and graph this.
Okay.
But okay, so the next one I said don't go to the end behavior, graph it first. To graph it though, we can find the x-intercept.
Mm-hmm.
The x-intercept is setting the inside part now equal to 1.
Okay. X is equal to -2.
You're just
Oh wait,
you're setting x plus 1 equal to 1. So
0.
you just subtract 1 with both sides. And then the y-intercept is f of 0. And you'll see that you have that from earlier.
Okay, so
Do you remember that value? Remember what
0?
it was? It is 0, yeah. So this gives us enough to start graphing this.
Okay.
So I mentioned like the first thing you really want to graph is the vertical asymptote, and that's x equals -1. So you draw a vertical line at x equals -1. Then you graph the 2 points. So in this case, the x-intercept and y-intercept are actually at the same point. So it's not super helpful because we do need that other point. But we at least have one now. So the last thing, in the last problem I said, to get that other point, I'm just going back to grab this function because I keep grabbing it. The other point I said, take the inside part and set it equal to the base. You remember that? That's the way to get the additional point. You said
Yes.
it. You said it equal to the base because you only got one here. Like sometimes the x-intercept and the y-intercept gives you the 2 points and you're done, but this gives you that other point for sure. So you subtract 1 from both sides. X equals 2. Okay, and what that does is it. And I kind of didn't give you the full information last time. What it does is turn this part right here, not the 2, but it turns this part right here into 1. I said it becomes y equals 1, but it's actually just this part right here that becomes 1. You still have to multiply it by that number on the outside.
Okay.
And so this equals 2, and that means that y is 2.
Okay.
So if I go back to the graph, I just add that next point, 2, 2, right there. And then again, I just make this kind of shape that goes through it, both points.
Okay.
All right, so let me go ahead and just scroll down here a little bit. We need to talk about increasing and decreasing. And again, I'll just grab that graph one more time. It's real quick to redo. We got that point, we got that point, we got that right there, and there it is. So where is it increasing? Meaning where is it going up, and to the right? Up and to the right.
It's similar to the domain, right?
Yes, it's the domain. That's the perfect word for this. The domain either goes in one position or the other. In this case, it's going to be x greater than -1. And we didn't talk about this, but it's always greater than. It's never greater than or equal to. It's always greater than. And then the other one is 0. So this thing is never decreasing. So you would say none or does not exist or something.
Okay.
And then the next thing we can do is end behavior. End behavior. So we can say as x goes to infinity, and this means to the right. So imagine going along this curve, but you're moving right. You're taking a path to the right. And it's saying, well, where do you go? How high do you go? Is what this is asking you to put in.
Positive infinity?
Yes. Okay, then the other one, it's a little bit awkward. It's as x goes to whatever the vertical asymptote is. The vertical asymptote is -1 in this problem,
Mhm.
but you're moving to the left.
Okay, so it's going down,
Yes, and how far down is it going?
negative infinity.
-infinity. Okay, so we have some options here that I can provide. One is to, I can graph some and have you kind of, we can look at some of the other cases, like what other things you might see. Like both graphs we did kind of look like this. They go up and to the right, they're moved kind of a little bit. You said though, hey, I haven't done that when I gave you one of those as an option. I apologize for that. Okay, so or I can give you a problem like the ones we just did and have you work on parts of it on your own, or something else. You tell me.
Can we do the second option, please?
Yes. I apologize. There was just some motion here. Okay, so let me give you a problem here. Let's say f of x equals. Have you done any negatives on the outside?
I think yes, we have.
Okay, so this will be a small change to. Let's go log base 4, and we'll go x minus 3 here. So there are two transformations, and I'm going to have you either tell me verbally or write them down and then tell me, have you kind of work through the rest of this together, but more on you than me.
The first one is a horizontal shift right of 3.
Okay.
And
What does this negative do? What does it do like when it's a quadratic is one way to.
is it a vertical reflection?
Yes, it's a reflection. It's better to say over the x-axis, because vertical could mean something else depending on who's interpreting it, but yeah. Okay, fantastic. So now I want you to find f of 0 and f of 1.
F of 0 is -3. So is it undefined?
Yes, after you put 0 in for x, and if you want to, like, you can actually evaluate it. This is a negative inside, so it's like you said, it's undefined.
Okay. And then f of 1 is -2. 2, which is also undefined?
Yes. Now, as long as you're writing what I'm writing here, you're going to be in great shape. Sometimes we say different things than what we write, but this is exactly correct. All right, so the next thing is domain and range. Go ahead and give those a try, please.
So the domain is x is greater than 3.
Yep. But you also have to include all that other stuff here. X such that X. Yeah. Okay. And what about the range?
All real numbers.
Okay. And perfect. Okay. So now the next thing I would have you do is find the x-intercept and then the y-intercept. And just like your instructor noted, may be none, but there's always an x-intercept.
Okay. Okay, so the x-intercept is 4.
That's right. You said x minus 3 equal to 1. So x equals 4. And we didn't really say it, but that y equals 0 is what that refers to. So it's this ordered pair. Okay. How about the y-intercept? Or are you still working on that?
For that one, so we use the y-intercept. So would it be undefined because when you use
Yes.
the f of 0?
Yes. So this gives you enough to make a start of a sketch of a graph. And it's hard to do that verbally, but the difference here is, actually, I'm going to move this over because most of the action's over here on the right side. So the vertical asymptote is at 3. And you told me that that's a point right there, 4, 0. What is the other point? And how do we find it? Do you recall that?
To find the second point. Yeah, I don't remember.
So you set the part inside the parentheses equal to the base. So do you remember what the base was? It looked like it was 4 in this problem.
Yeah.
Okay. So you add 3, you get x equals 7. Okay. You got to be careful here because if you go back to the original function, it was minus log base 4 x minus 3.
Mm-hmm.
So I'm gonna get that minus a little closer there. So this part right here is what becomes 1, but you have to apply whatever's on the outside there to it. So see how this becomes -1?
Yes.
Excellent. So the point is 7, -1. And this is the first one that's kind of different. 5, 6, 7 right there. So if you look at our graph, like we can't do kind of this up and to the right like we've been doing.
Mhm.
It's now down and to the right. And that's going to change a number of the things that we just that we do from here. But remember, what was the second transformation? What does the negative do? What does the negative do out in front?
It's a reflection, so it would flip.
Yep. So instead of it going up and to the right, it goes down and to the right.
Okay.
Very critical that's okay. And that's going to be the case when you get your negatives. So I'm going to redraw it, increasing, decreasing. So you get this, you get that point there, that point there. Okay, so where is it increasing? Where is it decreasing? I'll have you try that, please.
Okay. Okay, so the increasing is x is greater than 3.
But take a look here. Is this graph going up and to the right?
Oh, it's not. So there's none.
None. That's right. So some of these flip based on some things that could happen.
Yeah. Okay, so decreasing is.
So this is where what you just said goes to the decreasing side.
Oh, okay.
Okay, and then for the end behavior, as x goes to infinity to the right. So you're literally tracing this curve, you're going to the right, and you're asking yourself, well, how far down does it go?
F of x goes to negative infinity.
Perfect, that's correct. And then the other one, it approaches the vertical asymptote, which is 3. And the words are really more meaningful here, to the left, to the left.
F of x goes to positive infinity.
Yes. So we have done 3 problems today. They're very long problems. You have 2 from your page that you sent me. If you have any time at all to redo, one of them or more, I think you'll be in really good shape for your quiz.
Okay.
That does take us to the end of our lesson though for today. I will send you the notes here shortly. Thanks so much for scheduling, and I'll see you next time.
Thank you so much.
You're welcome. Bye now.
Bye.